Hey everybody, this is Larry. This is day 24. I I mean these days I'm not trying that hard to do the Hakaru thing. But I just don't know what day it is. Anyway, today's problem though is 1137 and Tribonacci number. We have this sequence which is Fibonacci. So maybe we're gonna go into dynamic programming and that'll be interesting. And this is going to be a very short video, not gonna lie. But so I'm gonna just say, yeah, if you haven't already, check out my other video on my other channel about, because I have a new channel that talks about the philosophy, I guess, of the mindset about problem solving in general and how to kind of approach it. I have a video on when to move on from a problem, which is another way of saying how to use Leetcode correctly, kind of, because I think a lot of people just don't really there are some philosophies you can disagree with it anyway. And my newest video is about does it matter what order you solve problems in and stuff like this, right? So yeah, definitely check that out. Let me know in the feedback, if you agree, disagree, and if it works for you, if it works not, right? Anyway, here I am just going to do it pretty quickly. This is Tribonacci, which is obviously very similar to Fibonacci. One thing that I would say is that there is this thing called the Q matrix, which you can use to solve Fibonacci in a faster way, which you don't need for this problem, but if you're interested in math, that's something that you can look up for. But it basically is also just saying constructing a matrix that allows you to do this calculation very quickly. That's basically the idea of a matrix exponent. Man, I cannot get words out. Matrix exponentiation. I'm still probably saying that a little bit off, but hopefully you know what I mean. But yeah, okay. For this one, we can just say, yeah. I mean, you can. I'm gonna do it the lazy way, but you can do it however you like. There is dynamic programming, and I think. I didn't get a good glimpse, but whenever I reset the problem, I still take a glance sometimes. Not all the time. I try really hard not to, but for this one, it doesn't even matter, right? And I think the last time I did the space efficient thing, so I'm just going to do it a little bit lazy today and mix it up. If you want to check out that video, it probably, you can look it up. And it was only like a year ago. So yeah, so here we can just calculate. Okay, well, let's just calculate for the nth number, right? And here they give you the formula, so it makes it very easy, right? Which is that if n is equal to 0, we return 0. If n is equal to 1, we return 1. If n is equal to 2, we return 1, right? That's what the base condition is, literally, right? And then otherwise, we can return calculate n minus 1 plus calculate n minus 2 plus calculate n minus 3. And that's pretty much it, right? In theory, right? I mean, I know, right? Yeah, this goes very fast, but is it fast enough? Well, here the beauty is that you can just put up the max case, and it probably isn't going to be. And yeah, and the reason is because this branches out 3 times, and also it does 1 operation per unit answer, if you will. So that means that if n is equal to 25, that means that it has hit either this one or this one a million times, literally. So for 37, that's even way bigger. Well, one thing that you can note is that every time we put in the same input, we get the same output, right? And here is the basics from basis for memorization, which is then now you go, okay, well, if it's the same every time and we get the same answer every time, then why don't we just save it somewhere? And that's how we do it. We call it cache for that reason, right? Or hash cache times n plus 1, so that you could, save 1 as well. And yeah. And then if it has cache, we can return. Otherwise, we can set the cache as you go this thing, and then we can return it. And that's pretty much it. A very easy way of saving things. Whoops. As long as you type it in correctly. And yeah, and you can see that this is, what is this, like 2 billion? I can see that, I can count the digits right. So yeah, give it a quick submit, and there we go. Pretty straightforward, I hope. Yeah, I don't know. Let me know in the comments if you have any questions about this. I think this is this, and well, I mean, Fibonacci numbers, I think is one of the more, one of the first things you do. So as in dynamic programming and memorization, so definitely try to figure out how to play around with it, play with variations, right? And yeah, and by itself, it's not that interesting. Actually, I take it back. Fibonacci numbers are very interesting. There's a lot of stuff with golden ratio and all these other things, but I just mean that, like, in terms of problem-solving technique, it may not be super interesting, but if that's the case, then you have to be super good at it, right? Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.